Yes. Okay. Good morning. Good afternoon to one and all. So we will start today our course sensor and application practical or experiment. Okay. So see, as we know, in the automation point of view, there are number of sensor it can be used. So this number of sensor it can be interfaced with some electronic circuitry. This number of sensor it is connected to electronic circuitry by interfacing this output of that sensor. It is again connected with that microcontroller, or we can call it as a computer. So see, in that whole process, we have already discussed that process in our theory. So number of sensor we are using for automation purpose, right? In any system, if we are consider any one of the system, we want to control that system. So for along with controlling equipment, we require some sensing equipment also. That means we require a sensor. So there are different types of sensor. In the theory, we have discussed some types of sensor. Can anyone recall that? In theory, we have discussed some types of sensor or classification of sensor. Yes. Not present? Yes. Have you attended? First lecture attended. First lecture. Okay. Okay. Input quantity or input physical parameter. Again, analog and digital type of sensor. Again, some active type and passive type sensor. Right. Some sensor absolute and relative type of sensor. Then some sensor depends upon classification. Some sensor it can be depends upon working principle. So that means according to working principle, there are electrical sensor. Some of the sensor depends upon conversion phenomenon, right? So in that we have discussed some resistance, capacitance type of sensor, right? Again, we have discussed some inductive type of sensor. Again, some contact type and non-contact type sensor we have already discussed, right? We have discussed one block diagram. In that block diagram, we discussed, or I will just recall that point. Okay. In that block diagram, we have discussed this block diagram in the first two lecture. So in that block diagram, this is the data acquisition system, and there are number of controlling equipment are connected. So some equipment are shown here, somewhat not shown. In that, one object is there. We want to sense that object, or we can call it as a stimulus. So stimulus is nothing but either the condition of that object we want to sense, either quantity of that object we want to sense, or some property of that object we want to sense. That means some we are using number of sensor to check the condition, to check the property, or to check the quantity, right? So this is object. Object, it may be anyway. So it is any kind of material, or it may be any kind of one type of object. We want to sense their physical property. We want to sense the quantity, as well as we want to sense the condition. Okay, we want to sense the condition, quantity, as well as we want to sense the property. so that there are number of sensor it can be used in this block diagram. So in that block diagram there are 5 sensor are used. In that 5 sensors, some sensor are on that object or it may be in that object. If we are calling it as a liquid material, if it is the liquid material, so we want to insert sensor in that liquid material, right? That means we can call sensor in that object. Okay, suppose we want to sense the one surface or any one of the object who is in contact with that sensor. So at that time we can call it as a sensor on that object, right? The object varti ahe. Similarly, this sensor 2, 3 and 4 are in the object or it may be on the object. Sensor 1, there is a no physical contact between object and sensor. Whether there is a physical contact, no physical contact. So we can call it as a non-contact type sensor. It is non-contact type sensor. So there is a not a contact between object and sensor, but always there is some energy transfer, right? So there is some energy transfer from sensor to object also, as well as object to sensor also. Then and then only this sensor it will be sensed. Either it may be condition, either it may be property, or it may be quantity, right? So this is non-contact type sensor, and these 4 sensor 1, 2, 3 and 4, these 4 sensor are connected as a input to that system. So this location it is called as which location? Extrinsic types of location, right? Extrinsic types of location, that means sensor which is used to sense the external condition, that means which is used to as a input of data acquisition system, it is called as extrinsic type of sensor. And this sensor number 5, it is nothing but it is the intrinsic location. So this sensor it is used to sense own state of that system, right? The system ची own state check करण्यासाठी sensor use केले sensor number 5. So we can call it as it is an intrinsic type of location, right? Intrinsic type. If we want to check the own state of that system, suppose system having a number of controlling equipment. Suppose in our power system, if you are considering one of the circuit breaker is there, right? Whether the circuit breaker is functioning or not. For sensing this, we want to use some sensor, right? So this is the intrinsic type of sensor or that control system. If we are using one sensor to check the own state of that system, it is called as intrinsic type of location. And the sensor 5, it is used to intrinsic type of location and to sense the system own condition, right? Again, sensor 4 requires some of the excitation, right? To enable its operation, it will require some of the excitation. So this sensor it is called as active type of sensor or active type of sensor, which required and some external energy or some excitation in the form of voltage source or it may be in the form of current source. So this is nothing but active type. And passive type, so it do not require an excitation circuit, right? It do not require an excitation circuit. Then some sensor it is connected to multiplexer via some of the interfacing circuitry, right? Why the interfacing circuitry it is required? Why interfacing circuitry it is required? We have covered no already. Why the interfacing circuit it is required? Yes. If the output obtained from the sensor it is not in the proper format, right? That means which is not in the readable format of that computer, or it may be which is in the not proper format to that of multiplexer, then we want to use some interface circuit, right? Suppose the signal obtained from the sensor, it is in analog form and it is a low level signal, right? So we want to convert it into high level signal. So this circuitry required is nothing but interface circuit, right? See, if the signal obtained from the sensor, if it is in not proper format, then we require and some interface circuitry in between multiplexer and output of the sensor. So here sensor 1 and sensor 3 output, it is not in proper format. So we using and one interface circuit. Sensor 2, 4 and 5, it is directly connected to multiplexer. That means the output obtained from the sensor, it is in the proper format, right? So that it is directly connected to multiplexer. What is the function of multiplexer? What is the function of mux? Function of multiplexer? So multiplexer, it is nothing but it is an one type of switch where the number of input circuit are connected, but output obtained from the multiplexer once at a time, or it will provide a output once at a time. You have performed the practical in case in multiplexer in your second year analog and digital integrated circuit ADIC subject, mux, demux. So that means we are able to connect multiple input to the top multiplexer, but it will provide a single output at a time. At a time, it will provide a single output, and this output, it can be fed to the microcontroller or it may be computer. ते जे output आहे ते कुठे फेड केलेलं आहे? Microcontroller or it may be computer. Okay. So see, in between that, one of the analog to digital converter, it can be inserted. So why analog to digital converter it is required? Why analog to digital converter it is required? Do you know computer or it may be microcontroller only reads the value in the digital format? That means either it may be reads 0 or 1. So to provide that value only in the digital format, we are using an analog to digital converter. So some sensor having an output, it is in the form of analog. Then we want to convert it into digital, so that we are using digital analog to digital converter. If some sensor output, it is in the digital format, it is in the digital format, so we not require analog to digital converter. We are directly fed output obtained from the sensor directly to the multiplexer. After multiplexer, we are feeding it to the computer or it may be microcontroller device. See, now the computer works on that output obtained from the multiplexer or it may be sensor. Sensor पासून जे output मिळालेलं आहे त्याच्यावरती computer काय करेल? Work करेल, right? Computer it will be work, and at that situation it will show some of the message in the peripheral devices. So peripheral devices, it is nothing but display, it is the alarm, or it may be some indicating type or some indication. That means some of the indication, and at the same time computer, it will be fed signal to the top actuator, and actuator again acts on that object. So this is the overall process of data acquisition system and its some control devices. In that not all control devices or it may be all circuitry, it can be shown. Somewhat data recorder is there, somewhat storing device is there, somewhat filter circuit is required. So this circuit, it is not shown in this diagram, so it will require some interfacing circuitry, some data recording, some data storage circuitry, it can be required. Some of the filtering, it is required. Some of the amplification, it will be required, right? So this here only by block diagram we are discussing regarding how sensor it will be work. It will sense, then it is fed to the multiplexer by using some interface circuitry. Multiplexer sense that output, or it will read that output obtained from the sensor, and it will fed only once at a time to the computer. right, to the computer, and computer process on that output obtained from the sensor. It will show the peripheral device. Peripheral device in the sense some display unit, some alarm type system, or it may be some indication type of equipment, or it may be indicating device, right? So for example, we have discussed one example, that is car door monitoring system. Car door monitoring system, suppose there are 4 door or it may be 5 doors of the car. Each and every door it is equipped with sensor. प्रत्येक जो काही डोअर असेल तो सेन्सरने काय केलंय, इक्विप केलंय, right? In that situation, this sensor it will act as a one type of switch. It is act as a one type of switch. It will sense whether the door is closed or door is open. Only two conditions are there, right? Door is open, signal obtained from the sensor is low level signal, that means 0. Door is closed, signal obtained from the sensor, it is in the form of high level signal, that means 1. Okay, suppose 5 door are there, this 5 sensor it is equipped with that door, and any one of the door it can be open, right? So signal obtained from any one sensor which door is open, that signal is 0. Okay, that signal is 0. So this multiplexer fed data, or it may be it will fed signal obtained from sensor sequentially to the analog to digital converter, but in the sense output obtained from the sensor it is in the digital format. Only two condition, either open or close. That means so door is open, that means 0 signal, door is closed, that means 1 signal, right? So that it is directly fed to the computer. Now what will do computer? Computer reads that output obtained from that sensor. Suppose sensor number 1 output it is 0, that means door 1 is open. Now it is fed to computer, computer process, and at that situation it will give signal to the peripheral devices. So peripheral devices, it is nothing but display unit. So on that display unit it will be display that door number 1 is open, right? Door number 1 is open. If door number 1 it is open, it is seen by the driver. So here the driver it will be act as actuator, right? Driver it will be act as actuator. It will seen that message displayed on the peripheral devices, and it will works on that object. काय होता ऑब्जेक्ट त्याचा? Which one object? Door. So driver काय करेल? Driver it will be act as actuator. It will either goes to that door, that means this line it can be shown. Either it will be goes to the object and then it will be close that door, right? Door close kar, or any person who is seated on that nearer to that door, so he will tell that just close that door. If the door it is closed, then output obtained from the sensor 1, again it will be read by computer, right? It will be read by computer, and computer shows that all door are closed, all condition are okay. So this is the block diagram, and this is the process of sensor, how the sensor it will be work, and this process it will be occur in the sensing and controlling up to our objective it can be achieved, right? So this is the sensor and controlling process we have discussed already. Now introduction of this sensor and application lab. In that course or in that subject we want to see some of the experiment. So this experiment we will perform by using not physically, but we are performing this experiment by using one software. Also we are using one VLab software, that is virtual lab, and we are using another one is nothing but Tinkercad. Tinkercad software is there. This software is free. Just we want to log in and we want to design that circuitry. That means how temperature sensor, how any one of the sensor, it can be interface with that device, or how it is interface with the Arduino, how it is connected. At the physical change, whether there is a change in the output side. So this we want to see by using a Tinkercad experiment, right? and we are performing some practical on simulation by using VLab. In that, some practicals are only introductory practical, or it may be what we can call theoretical practical or understanding purpose practical. So we will see one by one. Today we will discuss about all the practical list of experiment. From next lecture or next practical, we will perform each and every practical, right? See, in the introduction of sensor and application lab, there are list of experiment is there, that is characterize the temperature sensor. Okay, so temperature sensor or LM35, that is RTD, resistive temperature detector, is nothing but temperature sensor, right? Resistive temperature or resistance temperature detector, that is RTD, it is one type of temperature sensor. So we want to understand the characteristics, or we want to characterize that temperature sensor. So this is first one experiment. Second one is that another one temperature sensor is nothing but thermocouple. As we are discussing regarding explanation, while I am discussing active type of sensor and passive type of sensor, in that I am giving example of active type of sensor, that is thermistor or resistive temperature detector. Thermistor. So to enable that register, what we require? काय लागतं? Resistor मधून current flow झाला तर then there is a power dissipation. ना? Power, it should be dissipation in the form of which form? In the form of heat, right? So if you are considering resistive element or your heating coil, right? So it is having an highly resistive material. So when the current, it will be flowing from that resistive material according to heat law, then there is a heat dissipation, it will be occur, right? Heat dissipation, it will be occur. So when the current, that is heat law is nothing but when I square amount of resistance, I square amount of current, it will be flowing from R amount of resistance for a T time, then there is a heat dissipated, it is equals to I square RT. I know formula I square RT. In our machine, we can call it as a copper loss. Copper loss, it is also in the form of heat, right? So power dissipation, that is I square RT. So to enable that resistance, we required some current source or it may be voltage source. त्याच्यामधून current flow व्हायला पाहिजे. Then only it will dissipate heat. No? So that current source, we are giving any one of the external source or any one of the current source, that means we are giving excitation. So this is active type of sensor, right? Similarly, thermocouple, it is the passive type of sensor. Then to interface temperature sensor, this practical we want to perform by using Tinkercad. We want to designing that circuit, and we want to see the output obtained from that temperature sensor. To interface temperature sensor with Arduino. Next one, to interface humidity sensor. So for detecting an moisture or for detecting the moisture content, we are using an humidity sensor, right? So there are humidity sensor. This is like a capacitive plate. You know humidity sensor. There are so it will be like this. त्रिशूलला काय म्हणतो आपण? 2 terminals असतात त्याला, ते आपण डीप करतो. So one rod, it will be act as a capacitor, one electrode. Another one, it is like as a negative electrode or capacitor. Capacitor माहिती आहे ना? 2 plates, in between that 2 plates, what we are placing? काय असतं? Yes. Non-conducting material, that means we are that means putting insulation, right? No, so insulating material. So concept of dielectric heating also, it is also depends upon capacitive working principle. So two conducting part, in between that there is a insulation. So charge it will be transferred, right? So this humidity sensor, soil, it will be act as a non-conducting material if water content is not present. If water content is present, that means humidity is present, it will be like as a conducting material, right? So humidity sensor, there is a we want to interface that humidity sensor with Arduino, right? Next one, to interface LDR, that is light dependent resistor, right? So to sense the light, we want to using the light dependent resistor LDR, and it is interface, how it is interface with the Arduino, and the how output it will be obtained. Then next one is nothing but measurement of level in the tank using capacitive type level probe, right? Capacitive type level probe you are using, and we are measuring the tank of water level of that tank. Capacitive type of level probe we are using, and we are measuring the level in the tank. So this practical we will perform by using the simulation VLab, virtual laboratory. Again, next one is nothing but characterize of LVDT. Okay, linear variable. So I will tell long form of LVDT after that. Characterize the LVDT. Then simulate the performance of chemical sensor, right? So we want to understand here the pH. Do you know water pH? Pure water 7. If it will include impurity, distilled water 7 astu na, pure water sa. If it will include the impurity, whether it is less than 7 or more than 7. More than astu ka less than? Less than 7, no? So this we want to simulate the performance of chemical sensor. Then characterize the strain gauge sensor, and last one simulate the performance of biosensor. Okay, simulate the performance of biological sensor, or it may be biosensor. So this practical we want to perform. In that 10 practical we will perform minimum 6 to 8 practical. Okay, so this practical it can be performed by using VLab, or we are performing this practical somewhat practical, that is interfacing practical, by using Tinkercad. Right now we will give some introduction related to Tinkercad. Just go through the Google, type here Tinkercad. Okay, see, just you want to sign in. I have already signed out, sign in, so that just when I am putting my email ID, and if you put the password, you will go that dashboard, right? So in that, see, there is a some 3D design is there. we want to use the circuit design, right? So circuit design, just open. I have performed some network analysis practical also in Tinkercad. Also some of the sensor interfacing circuit in also Tinkercad, right? So previously I have performed, that is, here it is sensor. This practical I have already performed by using Tinkercad. Suppose we are considering one practical, that is okay. See, first of all, understood this is an circuit designing window. Okay. So before designing the circuit, you just search here different types of component. Which component you require for interfacing. So you just search here. On this side there is a some component is there. See here, some resistance, LED is there, then push button, potentiometer, capacitor is there, then different types of equipment like diode, ultrasonic distance type of sensor, then PIR sensor is there, temperature sensor, that is LM36 temperature sensor. So first of all, you want to choose that sensor, right? Okay. See, just select that, or here directly search. Suppose I required a breadboard, here directly search the breadboard. Okay, if a breadboard it can be searched, it will become, just click here and drag that breadboard on design window, right? And as per our connection diagram, do the connection. As per connection, there is a pin number is given. We are connecting one microcontroller, or it may be we are taking one Arduino, right? Or microcontroller. At the input side, we are connecting sensor. At the output side, we are connecting some display unit, or it may be it will shows output in the form of data, right? Whether you are not connecting the display, it will gives output in the form of data. Suppose we are changing the input value, like we are changing the temperature by somewhat degree, then output shows that now there is a 25-degree temperature. If we are changing input, then data obtained, output it is in the form of somewhat there is a 30-degree temperature, like that, right? So do the connection, and you want to perform this, simulate this. Here it is simulation. After connection, you just after connection, connecting all the equipment, giving a power supply. When you start simulation, so here start simulation button is there. So at that situation, it will provide some of the input, output. See, here it is, this is the temperature sensor. How it will be connected, we will discuss that at the time of performing practical. Just I am giving demo. That means now the temperature shown by display, how much? Display 24.71. Now I am varying the input temperature, or I am varying the temperature which is sensed by that temperature sensor. इतलं temperature मी काय करतो, vary करतो. Just I am varying this, so that means I am increasing. So output temperature 48.14. That means it will also increase. So how it will be interface with the Arduino, how it is connected. So connection diagram. I think in the microprocessor and microcontroller you studied regarding pin number. 14 pin IC or microcontroller. 8051 microcontroller. Recently we are using Arduino Atmega 328, Arduino Atmega we are using. So here this is the Arduino. We are giving power supply. Controller is also fitted 14 pin. We want to connect each and every pin connection. After connection and after simulation, we will got actual output, right? So output display by our peripheral device. Here this display is nothing but our peripheral device, right? Sensor, it will sense the suppose this sensor, it is contact type sensor and it is sensing the temperature of any equipment. Suppose this is one iron rod, and this sensor, it will sense the temperature of that iron rod, right? So at that situation, if the temperature of iron rod it is increases, sensor sense that temperature and it will be displayed to the peripheral device, right? It will display to the peripheral device. So this is the intersection, that means inter interconnection of sensor with all other circuitry like interfacing circuit like microcontroller, Arduino, or it may be it is connected with the display unit, or it may be peripheral device, right? So like that we want to perform. First of all, select all the component. Select all the component, which component you require. Just drag that component on the design window, make the connection and start simulation, right? So this is a very easy platform. If you want to do any practical, or you are doing practical as a humidity sensor, we are making one physical model. At that situation, initially we are doing simulation on that, or you do the simulation. That means you will better understand how it is connected. If the simulation connection is understood, that means you are able to do the physical connection. Yes, no? Connection करू शकतो ना आपण physically परत. So as per this connection, if you have connected your actual circuit diagram, then you are able to get the output, right? So that we are perform first simulation. This is the temperature sensor. It can be interfaced with the Arduino, and output it can be displayed by using a display unit. Here we are using LED display, right? 16:2 LED display we are using. Similarly, we will perform the humidity sensor practical. Interface the humidity sensor with Arduino. Again, we are performing the practical, that is LDR. LDR, that means light dependent resistor with that means with microcontroller, or we are interfacing with our breadboard, interfacing that with our Arduino and by using one breadboard. So some practical we are performing, that is interfacing practical we are performing here. Interfacing practical we are performing here by using an Tinkercad, right? Okay, see here somewhat practical I have already performed, that is LDR type of sensor, light dependent resistor. Again, humidity sensor and temperature sensor. That practical I have performed here. Remaining practical, some of the understanding practical, only understanding, and some practical we are performing by using simulation on VLab. You know VLab, virtual laboratory. VLab, this is the standard platform which is that means initiated, or this ICT enabled education started by Ministry of Education. Okay, so this is the valid platform. In that you should also practice, okay, how to use, how to simulate it. In that there are different types of or different branches is there. On that branches there are different experiment. It can be performed by VLab, and this is owned by some IIT institute, right? IIT Kharagpur, IIT Pune, IIT Mumbai, or it may be COE Pune. So here in electrical engineering there is a here it is one course, that is sensor modeling and simulation lab, right? Sensor modeling and simulation lab. Again here all the information is can be given. So theory related to that practical, procedure related to that practical, then how it will be performed, then target audience and course alignment, how it is aligned with that our course, our actual course, or it may be subject. So see, introduction, while sensor and application subject, we are giving introduction regarding simulation laboratory. The sensor modeling and simulation lab deals with working principle, then it deals with factor governing performance and identifying static and dynamic characteristics of major sensor. Okay, so what is the aim of this sensor modeling and in simulation laboratory is that to deal with working principle, that means sensor whose operation is dependent on working principle, that means working principle type of sensor, right, whose operation it is depends upon working principle. Some sensor operation it is depends upon factor, and so suppose we are considering temperature sensor, it will sense only temperature, right, it will sense temperature, no. So that means it is again input quantity type of sensor, or it may be input parameter type of sensor. Input parameter काय त्याचा temperature. If temperature sensed by that sensor, then and then only it will provide out, right. Suppose if you are considering object type of sensor, object type of sensor, so object it may be anyway, object it may be human organism, object it may be a solid object, object it may be a iron rod, object it may be one type of stone, any object, no. So object, whether there is a specific physical quantity, object it will sense any object comes in front of that sensor, within that range it will sense, right. Suppose we are considering path follower robot, path follower robot, have you know path following robot, it will follow the path, we are connecting one sensor, it will follow same path, that means it will sense that object. Path following robot, there is one white strip, or it maybe we can call it as a radium, no? व्हाईट स्ट्रीप यूज केलेली असेल, ज्या लाईन मध्ये ती व्हाईट स्ट्रीप असेल ती सेन्स करेल सेन्सर आणि पाथ फॉलो करेल, तोच पाथ, इट विल नॉट मूव हियर अँड देअर, राईट. एनी ऑब्जेक्ट सेन्सर, that means it will sense that object, whether it may be solid type object, whether it may be a any kind of object. Sanitizer machine, it will sense the hand or hand dryer equipment. Yes. Right. In front of that sensor, if we kept any device, it will do his work. Right? No. Whether it may be, suppose we are considering hand drying machine. If you kept a hand in front of that sensor, or if we kept any device in front of that sensor, it will dry that. Right? No. So that means any type of object, it is not depend upon specific physical parameter, or it may be specific physical quantity. Specific physical parameter वरती depend आहे का? नाही. So that means it is some depends upon that input quantity, some depends upon factor, some sensor depends upon working principle. We want to identify its characteristics. We are discussing in the theory, we will discuss regarding characteristics. There are number of characteristics of sensor, near about 20 characteristics of sensor. While discussing theory, we will discuss that. So there are some static characteristics, dynamic characteristics. So we want to understand that characteristics of each and every sensor, right. So characteristics, do you know that characteristics, it will provide some information. Yes, by understanding or by seeing any one of the graph, you can analyze or you can understood something, right. No, suppose in our motor nameplate there is a efficiency versus power output graph is there. You should analyze, no, at that much power output it will give an 70% efficiency, at that much power output it will give an 90% efficiency, right. So that means any graph, from any graph we are able to understand something, or it will show the behavior of that equipment or performance of that equipment. Suppose any linear characteristics, it can be drawn, voltage versus current characteristics. So it shows that relation between that two parameter. Characteristics or graph is nothing but it shows that relationship between that two parameter. जे काय दोन parameter असतील त्याचं relation show करतो, right? We are calling it as a linear. What is mean by linear? Starting from origin. Suppose this is one characteristics, voltage versus current characteristics. Here it is V, here it is I. It will shows whether it is linear or non-linear. Linear. So what is the meaning of linear? Okay, that means one quantity or output, it is depends on that input in the same proportion. We can call it as a direct proportion. So that means if little bit current change at the same value in the same proportion, there is a voltage, it should be also changed. That means we got some information from that characteristics, right? So this is these characteristics we want to understand for some major sensor. The first principal model, which is running in the background, will represent ideal characteristics. The configurable parameter will give the insight to student about the deviation from standard or expected field application. So here we are discussing we will discussing characteristics of that sensor in the ideal condition, or it may be ideal characteristics. Somewhat if you are using that sensor in the field, there may be some deviation, right? No, otherwise you people are telling, sir, we have performed the practical. In that practical, output obtained from that sensor, it is nothing but 80 degrees Celsius, but at the field it will be somewhat obtained 90 degrees Celsius. Okay, that means there is a somewhat a deviation, or it may be different. We are using here ideal sensor. Sensor is ideal we are considering, and there is a standard and expectation field application, somewhat there is a deviation. So this is main objective or main introduction related to that subject. Then sensor objective. Okay, what is the objective of inventing this lab is that, or this platform, VLab platform, is that characterize the different sensor by performing a test. Suppose we want to characterize the temperature sensor. Okay, temperature sensor is resistance dependent temperature, that is RTD sensor, resistance temperature dependent sensor. So in case of resistance temperature dependent sensor, what is the relation between RT and R0? If the temperature increases, we will go from basic. If the temperature increases, what is the effect on resistor? Any resistive material, if the temperature increases, you people already studied this concept in your basic electrical engineering, BEEE or BEE. काय इक्वेशन होतं? RT is equals to R0. RT, that is resistance at temperature T, it is equals to R0. It is nothing but resistance at initial temperature, or it may be zero temperature. काय होतं equation? RT is equals to R0 in bracket 1 plus alpha 0 T. BEEE मध्ये झालं ना? नाही, BEEE RT is equals to R0 1 plus alpha 0 T, where alpha 0 is nothing but, what is alpha 0? You have solved some problem also in case of BEEE. Not solved? Alpha 0, it is nothing but temperature coefficient, right? Temperature coefficient. So if initial temperature we are considering room temperature, so room temperature is nothing but near about 15 degree, or it may be 30 degree we are considering, or we are considering our body temperature near about, at normal condition our body temperature how much, 36 37, no? 35 37. So like that we are considering one room temperature, or it may be base temperature is nothing but R0. That base temperature, what is the value of resistance, right? And if the temperature of that material it will be increases, then what is the value of resistance? That means RT R0 into 1 plus alpha 0 T. Then what will happen if the temperature increases? Resistance is decreases or increases? Resistance increases ka or decreases? You understood that BEEE मध्ये आहे temperature coefficient as well as resistance at the temperature T, resistance R0 at the initial temperature. Okay, so this will be in the BEEE. What happen or what effect when the temperature increases? What is the effect on resistance? Any conductive material, what is the effect if temperature increases? कंडक्टर वरती काय इफेक्ट होतो? काय होतं? Okay, for example your incandescent bulb, right? No, there is a one resistive element is there, na? Tungsten element having an high resistive material, right? What happen if the temperature increases? Temperature increases, that means current increases, that is temperature increases. What happens? It will break, or it may be damaged. Why? Simple example I am telling. It is an high resistive material. That sentence I have used first. High resistive material. When temperature increases, if it is running for long time, or suddenly current flowing from that coil, it is increases. Again I square it is increases, that means temperature increases as per the heat law. I square RT. Resistance initially, suppose we are considering 100 ohm resistance of that coil, or it may be that element. Now this incandescent bulb is running for long time. Okay, that means this outer part of that incandescent bulb heated for a long time. Due to that, somewhat bulb it may be break, or if the current flowing from that input side, it will be increases. Due to that, again I square R, that means heat increases, it will be burst. What happened? I want to tell what is the effect of temperature on the resistor. If the current increases, that means resistance is not capable to oppose that current, or current increases, that means resistance decreases. Heat increases, that means resistance decreases or increases. The resistive materialचा resistance काय होतो? Decrease होईल. If we are considering outer temperature increases, or temperature of that element it will be increases, at that situation resistance of that material it is decreases. And if the resistance of that material is decreases, if we are considering same current, if we are considering the same current and the temperature increases due to resistance decreases, it will break. Understood? That means if the temperature increases, the resistance of material, it will be decreases. So depends upon material, whether material is conductive. Okay. Class. Okay, see, it is again depends upon types of material. Material वरती depend राहील, whether material it is conducting, material it is insulating, okay, or it may be it is a semi-conductive material. It is depends upon. We are considering if we are considering insulating material, what happen? हा ते जळून जातं म्हणजेच काय होतं, रेजिस्टन्स वरती काय इफेक्ट होतो? रेजिस्टन्स डिक्रीज होतो ना. If the insulating material, suppose we are considering one of the wire, so conducting wire, above that some of the insulating material is there. If the temperature or the current flowing from that wire, it will be increases. So due to that high temperature or due to that high current, the temperature of that conducting coil, it will be increased. If the temperature increases, insulating wire or it may be insulating material which are wound over that conductive material, it will be start melting. That means it will loses its resistive property. Barabar na? So it will loses its resistive property. So this is the effect of temperature on the resistance. So we want to characterize by performing or by conducting somewhat test. Not conducting, we are taking some temperature, we are considering some resistance, we are taking some of the resistance at somewhat temperature. That means defining first of all room temperature, how much resistance is there. Nextly, we are increasing the temperature. At that situation, what is the value of resistance? So we are taking somewhat 4-5 reading. After that, we are plotting a graph. That means it is characteristics, right? It will obtain the characteristics or characterize the sensor by under some test condition. Then identify and plot the static and dynamic characteristics of sensor. So that is static characteristics and dynamic. What is the static and dynamic? What is mean by static and dynamic? What is the meaning word static? Constant. And dynamic? So in case of DC machine, whether EMF it is induced statically or dynamically? Working principle झालेले ना? Check once again. Then select proper material of construction and allied component for specific application of sensor. So we want to select the proper material, whether we want to select tungsten material, copper material, platinum material. Okay, depends upon application where we are using the sensor. So these are the main objective. Again, under VLab, some of the list of experiment is given. Same, characterize the temperature sensor, simulate the performance of biosensor, measurement of level in a tank using capacitive type of level probe, characterize the LVDT sensor, then design an orifice plate for a typical application, simulate the performance of chemical sensor, characterize the strain gauge equipment, and characterize the temperature sensor. So these 8 experiments, just 5 minutes. Listen. See, list of experiment. Here is also under V lab. There is a list of experiment is given, and suppose I am opening any one of the experiment. Suppose I am opening characterize the temperature sensor RTD. Again, there are aim of that experiment is given. Theory of that experiment is given in details. What is the prerequisite of that experiment? Then theory, what is temperature from basic. It is temperature sensor. First of all, what is temperature? Then temperature dependent resistor. Then what is resistor? That is electrical resistor. So all theory it can be given. Why the proportion of current and resistance is there. Then how the temperature measured by using RTD, resistive temperature detector. Again, I think you people know equation of resistor. What is the equation of resistor? Resistance of any material, it depends upon R is equals to rho L upon A, where rho is nothing but resistivity, L is nothing but length of that conductor or maybe material, and A is nothing but cross sectional area of that material. So it depends upon R is equals to rho L divided by A. Suppose we are considering one conductor having an area, having an length, resistive temperature detector. So some commonly used RTD material is also given here. Platinum material, nickel, copper, Balco material, tungsten type of material, right? Then temperature calculation. So that I am telling equation RT is equals to R0 1 plus alpha 0 T. So RT is nothing but resistance at temperature T. R0 is nothing but resistance of reference temperature, or it may be room temperature if we are considering normal temperature, or it may be zero temperature. And alpha is nothing but temperature coefficient, right? So this is the graph again for this. सगळ्यांना okay. We will perform each and every practical from next lecture. So all of you attend practical regularly. So that's why you people understand the characteristics as well as how to interface that sensor with that microcontroller device, that means Arduino. Okay, and how it will be work. So it will how it will receive that signal and respond to that signal. That means sensor, it will receive the signal and it will respond to that input. Okay, so in this way we will conclude our introductory part. In the next practical we will perform practical. Okay, thank you. We will conclude and we will stop here.